What if I told you science can create diamonds in a lab, but struggles to create gold the same way? We can rearrange carbon atoms and make something harder than anything on Earth. So why can't we just rearrange something and create gold? The answer takes us from chemistry labs to exploding stars.
Let's start with something impressive. Diamonds are made of carbon. Just carbon. The same element found in pencil lead. The difference? Arrangement. In graphite, carbon atoms are loosely connected. In diamond, carbon atoms are locked in a perfect crystal lattice. Change the structure, change the properties. That's why we can create diamonds in labs. We simply apply extreme pressure, extreme heat, or use chemical vapor deposition. And we get real diamonds. Not fake, not synthetic imitations. Real diamonds. So naturally, the next question is, why not gold?
Here's the critical difference. Diamond is a form of carbon. Gold is not a structure. Gold is an element. It has 79 protons in its nucleus. That number defines it. Not its shape, not its arrangement. Its identity comes from its nucleus. To turn something into gold, you would need to change the number of protons in an atom. And that's not chemistry, that's nuclear physics. You can rearrange atoms chemically. You cannot easily change what element they are, because elements are defined by proton count. Hydrogen, 1 proton. Carbon, 6 protons. Iron, 26 protons. Gold, 79 protons. To create gold, you would need to take another element and either add or remove protons from its nucleus. That requires nuclear reactions, not chemical reactions. And nuclear reactions require enormous energy. Gold is not formed inside normal stars. Stars fuse light elements like hydrogen and helium. But gold? Gold requires something far more violent. For decades, scientists believed gold formed during supernova explosions. When massive stars collapse and explode, they create extreme temperatures and neutron flux. But in 2017, something even more dramatic was confirmed. Gold is primarily formed when two neutron stars collide. These are ultra-dense stellar remnants. When they crash into each other, the explosion releases immense energy and floods space with neutrons. Atoms rapidly capture neutrons in what's called the R process. And in that chaos, gold is born. Every gold ring on Earth was forged in a cosmic collision, before Earth even existed. Technically? Yes. Physicists have created tiny amounts of gold inside particle accelerators. By bombarding mercury atoms with particles, they altered the nucleus. For a moment, they produced gold. But here's the problem. It costs millions of dollars to create atoms worth fractions of a cent, and often the gold isotopes created are radioactive. They decay quickly. So while possible in theory, it is completely impractical. You cannot industrially manufacture gold. Not economically, not safely. For centuries, alchemists tried to turn lead into gold. They weren't crazy. Lead has 82 protons. Gold has 79. They were actually close in proton number, but they had no understanding of nuclear structure. Without nuclear physics, transmutation is impossible. It wasn't until the 20th century that we even understood what makes one element different from another. When you hold gold in your hand, you are holding matter that was born in stellar catastrophe. It survived. A neutron star collision, billions of years drifting through space, the formation of our solar system, the birth of Earth. Gold is rare because the universe doesn't make it often. It requires chaos, violence, cosmic extremes. That's why it's precious. We can rearrange atoms. We can mimic pressure. We can simulate chemistry. But we cannot casually recreate the death of stars. Gold is not just a material. It is a fossil of a cosmic explosion. So the next time someone asks, why don't we just make gold? You can answer, Because gold isn't built in laboratories. It's forged in the most violent events the universe can produce, and we don't have that kind of power.